Hi, I'm Kumar from Mechanical Department. In this video, we'll discuss about different types of welding process. So now move on to the topic. So first thing, so what is meant by welding? So welding is a process of joining of two similar or dissimilar metal by applying the heat. Okay. Uh, Second thing, so two types of welding process is that is a fusion welding process. So after that is the plastic welding. First thing, we'll discuss the fusion process. The first thing that is by using consumable electrodes. So those are the different types of classifications. So there is a consumable electrode based on the consumable electrode means that is the process that is a SMAW, shielded metal arc welding. So after that GMAW, that is a gas metal arc welding. So after that SAW, that is a submerged arc welding. So in this types of welding we are using that is a consumable electrons. So after that, so non-consumable electrodes, there is a GTAW, that is means the gas tungsten arc welding process. So after that, that is a PAW, that is a plasma arc welding process. So after that, using a high energy beam, that means the electron beam welding process. After that, that is a laser beam welding process. These are the classification of based on the electrode, that is a consumable electrode. After that, non-consumable electrode using a high energy beam. So these are the different classifications. So first thing, that is a shielded metal arc welding. So the other name is that is a stick welding. So this is the basic type of welding process. Nowadays we are widely used in that all areas. So in this SMAWR shielded metal arc welding process using a consumable electrons, it's based on the welding material. If a welding material is mild steel, means the electrode also is in the same metal. So in this picture, this is a core wire. Core, I mean, that is a welding wire. So after that, the outer side is that is a flux coating. That's like a powder form. Um, so it is mainly used in the used it is mainly used for to prevent the oxidation during the welding process. So this is the base metal, that is base metal, that is the welding metal. The gaseous shield is formed during the welding area, and this portion is that is a slag covering, that is a um, the flux coating is converted into that is a slag covering area. So and this is a welding metal. The slag covering area is covered by using a welding metal. So using a flux coated rod. So after that, the flux produces a protective gas around the welding pool. The welding pool is that is a welding area. So after that, the slag keeps the oxygen off. That means prevent the oxidation during the welding. Simply prevent the oxidation during the welding. So after that, it's a widely used welding process. It can We can weld the thickness of 1 by 8 inch to 3 by 4 inch. It's a mainly portable, one of the portable welding process. The the current range is 50 to 300 amps. So after the voltage range is that is 15 volts. So after that, so these are the current and voltage used in that SMAW welding process. We are using two types of polarities. One is a straight polarity. So after that is a reverse polarity. In a straight polarity, the electrode is connected with the negative terminal. So after that, the workpiece, that is the base metal, connected with the positive terminal. So in this straight polarity, straight polarity, we use this type of polarity in a shallow penetration and also used in the thin metal. So another one is that is a reverse polarity. In this type, the the welding rod connected with the positive terminal. So after the workpiece connected with the workpiece or base metal connected with the negative terminal. So in this type of polarity used in the deeper weld penetrations. So after that, second thing, that is a GMAW, this is a gas metal arc welding process. So these are the layout diagram of gas metal arc welding process. The another name is that is a MIG welding, metal inert gas welding process. In this process, the wire is fed from the one place. So in this process also we are using the consumable wire electrode. The shielding provided by the gas. In this welding, we are using argon, neon, that is the inert gases. We are using inert gases like argon and neon. So mostly used, that is argon gas is mostly used. So after that, in this process is easily automated when compared to the other process. This is a welding nozzle, right, or welding torch. So in this welding, DCC reverse polarity is mainly used. That is the hottest arc. So after that, in AAC means that is the unstable arc. So next one is that is the submerged arc welding process. So in this process also use the consumable wire electrode. This shielding, the shielding provided by the flux granules. So in this type of welding, the flux is used in the form of granules. So after that, that is in this process the low UV radiation and then fumes, because the welding wire is immersed in the flux granules. So the arcs takes place inside the flux granules. The flux granules act as a thermal insulator. So this process also easily automated when compared to the other process. So and also this process is high speed and then high quality. We can obtain the high speed and then high quality welding. The speed up to that is a 4 to the 10 times and compared to the SMAW, right? It's mainly suitable for the thick plates. The voltage range is that is a 440 volt. After that, that is a ampere range is that is a 300 to 2000 amps. So the next one is that is a non-consumable process, GTAW, that is a gas tungsten arc welding process. It's a non-consumable electrode. So in this non-consumable electrode, so tungsten is act as a non-consumable electrodes. In this process is carried with or without the filler metal. The shielded gas, the shielding gas is mainly used argon. So after that, it is used for thin sections of aluminum and then magnesium and then titanium, right? It's the most expensive process, and also we can get the high quality welding. So the current range is that is a 200 amps for DC and 500 amps for that is a AC, and also the power consumption is 8 to 20 kilowatts. So and then the laser welding. So in this process, the laser is produced by a CO2 or that is a YAG, that is a York laser. So in this type of welding, we can obtain the high penetrations and high speed. So that is a concentrated heat. That is a concentrated heat is equal to that is a low distortions. Okay. So after that, the laser can be shaped and focused to the particular pointed area. So in this process is easily automated, and then we can obtain the high speed up to 250 feet rate per minute. So that we can weld the workpieces up to 1 inch thickness. So it is it has a wide range of applications. So medical devices, and then small parts of and components, and then fine wires, and then jewelry, and then small sensors. So materials down 1 inch. So after that is a solid state welding process or plastic welding process. The first one is that is a friction welding, diffusion welding, and then ultrasonic welding, and then resistance welding. In this solid state welding process, there is no filler metals, there is no wire electrodes, there is no shielding gases. So first thing, friction welding. So the other name of this welding process that is the inertia welding process. So in this process, so the one part is rotated, then another one part is stationary. The stationary forced against the rotating parts. At the time, the high heat will be produced. At the same time, the friction converts the kinetic energy into the thermal energy. The thermal energy is heating the two end of the workpieces. At the time, the metal at the interface melts, and as a joining is occur. So these are the welding process. So that the resistance welding process. In this type of welding, the heat is produced by the resistance to electrical current, that is the Q equal to I square, that is I square RT. So in this process, 0.52, that is a 10 volts, but the current range is that is a 10,000, that is a 1 lakh amps. The force applied by that is a pneumatic cylinder. There is a two types, that is a spot welding and then the seam welding. So this is a diagram of a resistance welding process. So the parts are forced together at the high temperature. The parts forced together at the high temperature. So after that the heated in the furnace or by resistance heating. The atoms are diffused across the interface, and also after the sufficient time, that is interface disappears due to the cooling process. This welding process is very good for dissimilar metals. So next thing is soldering and then brazing. So in this process, only filler metal is melted, so not the base metal. So in this process, filler metal only is melted, so not the base metal. The temperature is when compared to the lower than the other welding process. The filler metal is distributed by capillary actions. So the metallurgical bond formed between the filler and then base metals. So the strength of the joint is stronger than the filler metal itself and then weaker than the base metal. So the gap at the joint is important. That is gap mean that is a 0.012 to 0.010 inch. That is can join the dissimilar metals. It can join the dissimilar metals. We can use the less heat when compared to the other welding process. Can join also the thinner sections. So the excessive amount of heat during the welding can weaken the welding surface area. So next thing that is a soldering process. So solder mean that is a filler metal. Uh, the alloys of tin like that silver, bismuth, lead. The melting temperature is typically below the 840 Fahrenheit. The flux is used to clean the joint and then prevent the oxidations. We already discussed in the SMLW welding process. Separate are in the core of wire, that is the rosin core. So tining, the pre-coating with the thin layer of solder, it called as a tining. So tinning. So the main applications is to soldering the printed circuit boards, that is a PCB manufacturing. So after that, that is a pipe joining process, the copper pipes. and then jewelry manufacturers, and also the typically non-loaded bearing. So easy to solder, that is a easy to solder means that is a metals, that is a copper, silver, gold. So difficult to solder means that is the aluminum, aluminum, and then stainless steels, right? So next thing, that is the brazing. Uh, we can use the use of a low melt point filler metals to fill the gap between the matting surfaces. The filler metals include, that is the aluminum and magnesium, then a copper alloys. So the melt point typically above the 840. In the soldering process, below the 840, but brazing is, that is above the 840. So in this process, the flux is also used. So it has the three types of brazing, that is a torch, furnace, and then resistance. So the main applications is the automatic joining tubes. So after that, that is a pipe or tube joining process in the heating, ventilations, and then air conditioning process, and then electrical equipment joining wires, and then jewelry makings. So the joint can possess the significant strength. So in this video, I hope this video is very useful to you. So thank you.